Okay, hello everybody. Let's start with a very small example. So I have this tiny program, only 3 lines, seems pretty straightforward, but let's see if we can type check it using Mypy. So I guess first you need to install Mypy, just use pip install Mypy. Now you need Python 3 to run Mypy. It's a Python 3 application, but you can use Mypy to type check also Python 2 code, which we'll talk about later. And then the simplest way to type check and code is run Mypy, name of the file. And actually, it turns out that this program has an error. So reversed returns an iterator, and you can't append to an iterator. So great, Mypy found a bug. Nice. So what exactly is Mypy? It is a static type checker. So static in this context means that it analyzes your code, like tries to understand some aspects of the code, but it doesn't actually run the code. So it has no idea like what is exactly happening at runtime. So it tries to find type errors, things like missing attribute, calling a function or method with the wrong number of arguments, or like wrong name for keyword argument, or wrong argument type, and things like that. And it needs a bit of help from the programmer. So you need to add type annotations to your code to actually have Mypy do useful type checking. So the type annotations are part of like Python. They are standardized in PEP44, that was mentioned briefly. And like Python 3.5 comes with a typing module in the standard library, which kind of we are going to use later on. So okay, now I'm just going to give you a very brief overview of how you like annotate your code. So I'm not going into there's like a large number of different kinds of types. You can use it pretty flexible, but you can get started with just like a couple of basic things, and then you can gradually kind of learn more stuff as you go on. So here's a slightly more complicated example. So here we have a user-defined class cats, which has, and this has type annotations. So here we have a Python 3 type annotation for the $init method. So the argument color has type str. It just basically reference to the built-in str class object. And then also $init doesn't return a value. So we have a return type that's like arrow none, which means that it doesn't return anything. Well, implicitly it returns none, but we don't really mostly care about that. Another slightly interesting thing is like the self argument isn't annotated. Mypy is clever enough to figure out that the type of self is cat. So there's no need to kind of explicitly kind of add that sort of redundant information. And then the body seems kind of straightforward. There's actually something interesting going on there. So Mypy, by looking at the body of $init, Mypy figures out, oh, the class cat has an attribute called color. And also it does type inference. So it looks at the initializer, which is just the expression color. And the type of that is string, so it infers that the type of the color attribute is also string. So you don't need to annotate that explicitly. And usually, you don't need to annotate variables, just functions. And then I mentioned the typing module. This is in the standard library, and there's a backport for Python 3.4 if somebody's still using that, and Python 2.7. And it is a bunch of types and utilities that are very helpful. And almost all non-trivial code using annotations will use some of those. So in this case, we imported the types to iterable and set. And we use them in the annotation for the function all colors. So the cat argument is an iterable over cats. So we use square brackets to kind of build more complex types out of kind of simple types. And also there's a return type uses square brackets to say this is like a concrete set object with string items. And actually, if we run Mypy against this program, it finds another error. Nice. Okay, we've misspelled the color attribute. So obviously, it should be written like that. And now it's green. So Mypy, and again, Mypy needs to know the type of cats to kind of know that the color attribute actually is misspelled, because otherwise it would have no idea of saying what is supposed to be inside cats. Okay, another example. So in this case, we just have like tasks, which is an empty list. And actually, like Mypy kind of complains if you write a type-tested program because like it doesn't have enough information to decide what the type of the list item is. So you need to help Mypy a little. In this case, it's straightforward enough. So okay, you just import another like type from typing, and then we add a type annotation. So this is like variable type annotation, which was added in Python 3.6, which is pretty nice. And you can also leave out the initializer if you just want to declare the type of a variable. So this kind of helps Mypy a bit. But what if we actually are not sure what the item type is? Maybe there's some legacy code that nobody understands anymore. So in that case, and in general, if there's a type that you can't kind of figure out, you can always fall back to any, which means basically unknown something. So Mypy kind of lets you put anything within that list. So it's kind of a cost. It can't type check as much, but then it gives you more flexibility. So you can use this, but you shouldn't use it too much. Okay, I mentioned that like you can also type check Python 2. So these, obviously you have to use a slightly different syntax. In this case, this is also standardized in PEP 4.4. You have type comments. You can have different type comments for functions and variables. And the variable type comment is also useful in Python 3.5, which doesn't support the variable annotation syntax. And again, like there's a backport for typing for Python 2 that you have to like pip install that. And then you can basically do all the same stuff, except with a slightly different syntax, or well, quite different syntax. And if you type check using Mypy, then you should use the --py2 option to run Mypy in Python 2 mode. And you can also like have Python 2 and 3 directly encode and just run Mypy twice with different options. And note about Python 3.7. So Python 3.7 added some pretty cool stuff related to typing. So you should really consider upgrading to Python 3.7 if you're still using like something else. In particular, I like the from future import annotations thing, which might not sound like much, but actually makes life much easier. So it lets you have forward references in your types like this, just like as you'd expect. So label is defined after the like label attribute. In Python 3.6, you have to use like string literal around the label in the annotation, which is kind of ugly. So just jump straight to Python 3.7, and you can just forget about that problem. Okay, so now you have a general idea of how types work and what Mypy is, but should you use types? What's the point? The main thing that we've heard like over and over again from users and like other people giving talks about Mypy and everything, it's just like type annotations make code much easier to understand because they act as machine-checked, machine-verified documentation. And this is something particularly important for large code bases if you have like a team of multiple programmers working in the same code. So you can't expect everybody to understand everything. And these types really make code understanding much easier. And obviously, types can find bugs early. So basically, you should run Mypy like after like maybe each change you make, not even trivial ones, to make sure that you didn't have like a typo or something. So because it's like the faster you find bugs, the easier they are to fix because you just remember the code better. So like fewer bugs in production, which is obviously another big benefit. There's also like a slightly less obvious thing. By increasing readability, people are less likely to make mistakes by misunderstanding the code. So like calling a function with, say, like wrong argument that just happens to run due to tug typing, but it might produce something completely bogus. So type checking kind of can catch those sorts of issues. So again, like fewer bugs thanks to typing. And both of those kind of mean that you spend less time reading code, less time like fixing and debugging issues in production, which means like more productivity and more time to do actually useful work, productive work. And there are a couple of other big things that are kind of slightly less obvious, is like IDEs like PyCharm and Visual Studio Code can take advantage of type annotations, and they can like give you better like code completion. In PyCharm, like go to definition, etc., work better and more reliably. Again, like especially if you have a large code base, like the automatic type analyzers don't work that well. but if you have type annotations, then kind of it scales much better and works more reliably. And also, like, types make refactoring easier. Things like generally you can, if you like, modify the signature function, generally you just modify the annotation and then run Mypy, and it'll show exactly which part of the code base needs to be updated. Not like you get some like weird exception in your tests or maybe in production because you forgot to update something. So this is really, again, like improves productivity, and also it makes it easier to refactor, so that's you're more likely to refactor code, which means that your code is cleaner and you are less likely to introduce bugs because cleaner code is also less buggy code. So all of these benefits are kind of, they might not be obvious from the beginning, but if you actually start using types, soon you'll be kind of getting the benefits. Okay, another thing that Mypy lets you do is gradual typing. So most users of Mypy, I'd expect, started with an existing code base without any type annotations. The idea is that you can start with annotations and then start gradually add them until you reach like a reasonable level of coverage. You don't need to go like to 100%. But this is a great thing because it makes migration easier, but there are some issues you should be aware of. So this is another like really tiny example. We have like two modules, A and B, and B calls function f in A, and obviously like, well, it'll blow up because you'll add an int to a string. So what if you run Mypy? Actually, Mypy says like, okay, I can't see any problem. Why is this? Well, the thing is, Mypy doesn't type check functions without annotations. This is to make the gradual typing easier. So if you have like huge numbers of legacy code, then often like Mypy will generate some kind of warnings about things that it kind of can't figure out. And you might get like hundreds of errors if you try to like type check everything in one go. So basically the idea is to gradually add annotation coverage, which means like if you don't have annotations, then there's not much Mypy can do. So basically, okay, let's add an annotation. But again, like, what? There's still no error. Well, the thing is, Mypy still doesn't know what f returns because it doesn't have an annotation. So it still like f returns something, maybe you can add it to string. So now when you actually also annotate f, then Mypy can find the error. So basically it means like, instead of just annotating code, you might need to like other code that the code interacts with to get like actually useful type checking results. So if you have few annotations, you get some checking, but not that much. If you have more annotations, then more checking. So that's kind of the thing to remember. It kind of like, and that's kind of something that some people complain about. They don't understand this, and they don't, why can't Mypy catch this error? So this is really important thing to understand. Okay, now assume that you have some existing code that you'd like to migrate to static typing, and you haven't used Mypy before, so no annotations. So the first step I recommend is to try to get Mypy to run against some code without adding any annotations, other than the minimal ones to get a clean Mypy run. So again, like as I said, like you might have to tweak things a bit. Maybe you do some like dynamic stuff that Mypy doesn't quite understand, or something else like you need to might add some annotations. So it takes a bit of work. I'd recommend starting with maybe like 5,000 to 20,000 lines of code. That's really like a reasonable size. So if you have like 1 million lines of code, you shouldn't kind of try to get that all running under Mypy. So maybe like 1 or 2 days of effort, and you should get a like lead run for that kind of subset of your code base. And maybe that's all your code, then great, then you're kind of doing well. But the thing is like, how do you kind of pick the like 20,000 lines of code? That's kind of, can be a bit tricky, so I'm going to spend some time talking about that. So I guess the simplest thing is to only type check specific directories or specific files, just like Mypy and some paths, which is great. It works. That's what you'd expect. But obviously, if you have like 100 directories, you don't want to enumerate them explicitly. So it doesn't really scale to like really large code bases. And there's a slightly more general thing you can do. It's kind of similar. So you can have like regular expressions or like glob patterns, which kind of used to kind of pick up which files not to type check, or maybe, so basically you can use a blacklist. Alternatively, you can use a whitelist, which are like have patterns which match the files that you want to type check. In this case, like we don't want to type check test code, so we have this like /test/ pattern. So you probably won't want to use exactly this thing, but something similar might work for you. But then again, like this kind of is more scalable than previous one. It still kind of doesn't scale to like tens of hundreds of files, probably. Okay, this is what we use at Dropbox. So we have like tens of thousands of files. We don't want to maintain like manual lists. So we also have like blacklists, and actually we probably use all of these in some capacity. But we also have this like typed comment kind of detection script, which kind of looks for files with type comments. And then we include all those files in the build. So that the moment you start annotating file, it gets automatically picked up by the Mypy build. In Python 3, you might like have a like regular expression which looks for like type annotations or imports from the typing module, or you can invent your own kind of marker. So that way you can kind of pretty easily add new files to the build without having to modify some configuration file. So you have to do a bit of scripting, but it should be pretty straightforward. Again, like this is a problem that maybe you don't have that like a type annotation in a file because it doesn't have a function. Or you forget to add the tag, then you're kind of like problem because then Mypy doesn't see that file. So these are kind of trade-offs you need to think about this carefully because it's kind of hard to change these like 6 months into the project. And if you have really lots of code, then Mypy has this follow imports option, which kind of decides like what should Mypy do with files that are imported from the files you pass it on the command line, but that are imported from those files but aren't included in the command line. So skip means just like, okay, only type check these files on the command line. There's also a silent option which kind of processes those files but doesn't generate errors. This can be useful because otherwise you might get like large number of errors from Mypy on your first run. So this is like a good thing to try. Okay, next time I'm going to take something that's kind of directly related to the previous topic, but you'll hit it pretty quickly when you're like annotating any real code. So Mypy uses stub files to describe types in library modules. There are stubs for the standard library and a bunch of third-party packages. Mypy ships with stubs, so if you only use the standard library, then some like common third-party modules, it might just work. But the thing is, Mypy complains if it can't find a stub because then it can't type check your code and it doesn't want to kind of silently kind of start ignoring stuff. You can recognize stubs by the .pyi extension. Again, this is like standard. So what if you are using a third-party library and it's missing a stub bundled with Mypy? So one thing is you can look for like an external, maybe somebody has contributed a stub, you can like Google, or there's also a recent PEP 561, which lets you install stubs using pip install, which is nice, but unfortunately it's kind of a new thing, so there aren't that many stub packages available. But if you write new stubs, you should consider contributing it to the community. Next thing is you can just use a type ignore comment, which means that don't report any errors on this line. So you get, okay, we don't ship with SQL Alchemy stubs, but it's not a big problem. You just like type ignore the problem. It makes it kind of explicit that Mypy can't type check. It uses SQL Alchemy, but it can do a lot of type checking for other stuff. And maybe so this is like, if you only have a few errors, this is like an easy way to do it. And it works for other kinds of like complaints that you can't figure out. Just ignore it initially and then like commit back to it later and see if you can fix it in a kind of more better way. What if you have like a lot of like 50 imports to SQL Alchemy? In that case, you can create a mypy.ini configuration file, and you can just tell Mypy to ignore all missing imports targeting these packages, like maybe Bodo, SQL Alchemy, and then those go away. But if you import from something else, then you'll still get an error. So it's kind of like you can like accidentally like paper over like a large number of errors. Only those things that you don't want Mypy to report. Okay, now that you have a clean run from Mypy, then you have a way of running Mypy, which against some subset of your code base, or all of your code base, depending on the size. You should commit that script into your repo and have everybody in your team use that to run Mypy because you want consistent results. This is, again, should be pretty clear, but it's important thing to remember. And once you have the script, then you can run the script in CI to make sure that nobody will introduce additional errors accidentally. Or at least you will catch them pretty soon. The fourth step is going back to the modules A and B. you should add annotations to commonly imported library modules, because otherwise, like if these modules are used all over the place, then each time you call something in that module, Mypy thinks it's, I don't know what it is, it's any, and it can't do much type checking with the result. So pretty early on, you should annotate a bunch of library functions and classes. This will greatly increase the coverage, and actually Mypy will catch more errors pretty soon. And then you should kind of talk to your team and kind of establish guidelines. It's like if you edit a file, you should add functions to the modified add annotations to the modified functions. If you write any new functions, you should annotate them. So this way, you'll gradually get more and more annotations in your code. And that's because when you're writing code, you should understand what it's going. So writing the annotations should be pretty straightforward. So it actually, you'd have to write a doc string anyway. So this actually saves time because annotations are more compact. So you save some time, and you get like more type checking coverage at the same time. So it's a win-win. And then at some point, you should probably look at your legacy code and try to start annotating that, because it will kind of leak some like imprecise types to the other parts of your code base. So you can do it manually. It works pretty well. It's kind of boring, but it's not that much work. Or there's tools like MonkeyType and PyAnnotate, which let you collect types at runtime. So for example, you can run tests. They can collect like the actual runtime types, and then they can generate draft annotations to your code. They aren't 100% correct, but you can often like you just slightly manually tweak it. Then you can actually get like a lot of code annotated without too much effort. But again, like you need to give it a try. They may work, but sometimes they have some rough edges. Okay, now you've been adding a bunch of files to your build. Maybe you have like, this means like Mypy runs might be a bit slower because it's doing more work, so it's useful, but obviously like faster is better. So there are a couple of things, pretty recent Mypy features that can speed up Mypy runs by maybe 10x or even more. There's a Mypy daemon which keeps like the program state in memory, so that like if you do incremental builds, it'll only have to like reprocess the modified files. That's a really nice thing. And you can also do something like remote caching to basically download like a recent snapshot of the Mypy internal state, so that you can then only have to do an incremental build on top of the most recent incremental state instead of like processing the entire code base every time you say switch to another branch. So this is a summary of the steps. We should kind of get you started. Then obviously there's more advanced topics, and you should read the docs afterwards and see whether there's like other stuff you want to experiment with. And finally, I'll talk about a few mistakes beginners might make, and I want to kind of have you avoid these. The first mistake is like, I'll just start with this single file which I'm working on, and I annotate it with Mypy. I use Mypy to type check it, and then I get a like, good idea of how Mypy works. This is not true because, as I said, you need to annotate like the library modules and other modules your code interacts with. Otherwise, it might look like Mypy doesn't check anything because you haven't annotated that much. So this is not a good way to get started. Another mistake might be like, oh, we just like write annotations, all new code that we write. So in like 12 months, we have like a lot of our code annotated. Again, like this misses all the legacy code. You probably have a lot of code that doesn't get changed in 12 months. And that will never get annotated. If you should like annotate the legacy code as well outside the normal kind of coding workflow. And then mistake 3 is like, oh, we have this million lines of code. Let's type check everything. And then you might get like, I don't know, 500, 1,000 errors that you need to, and then, oh, I give up. It's too much work. Yeah, you should start with like maybe 20,000 lines of code and then gradually increase it. So there's no like big bang sort of integration, which is pretty demoralizing. And if things go wrong, then you wasted a lot of time. So I think start simple. OK, and quickly, I'm going to talk about our experiences of using Mypy at Dropbox. So we've been using Mypy since pretty early days in Mypy, yes, since 2016. We currently have over 2 million annotated lines, and pretty much all teams using Python use Mypy at Dropbox. And this can be like organic growth. People just like see it's useful for them, so they start using it. And we've kind of improved Mypy on the way, so to get like basically more teams on board. And currently, we are using Mypy daemon, which I briefly mentioned, and we get like incremental runs. We get like telemetry from users. Typical incremental run takes about 2 seconds, even if you have like millions of lines of code, so it scales pretty well. It was much better than it was like 6 months ago, so this is really improved. We also use a remote cache that I mentioned, so that like it also like when you start run Mypy for the first time, it's also much faster. And then we have a PyCharm Mypy plugin, which is open source. You should look it up if you use PyCharm. It's really kind of makes it easy to run Mypy from PyCharm and kind of jump to the error. It really kind of simplifies the workload. It's really smooth. So that's all I had. Thank you, everybody.
Thank you, Jukka. If you have a question, please, can you raise your hand? Paul.
Thank you. Great talk. My question is about stub files. Supposing I've got a bunch of C++ code that's exposed to Python, do you know of any way of being able to generate those stub files from the C++ binary?
Mypy ships with a tool called stubgen, and it can do some like runtime introspection of C extension modules, and it'll try to generate some draft files. So you can give it a try. The thing is, it's kind of impossible to do that like 100% reliably. So basically, if it's simple enough, it may work. If not, then it doesn't work. So basically, try it out.
Just a quick question. So does it support Python 2.7 at all?
Python 2.7 is fully supported as a type checking target. So you can use the type comment syntax. You just run mypy --py2. That's actually what we use at Dropbox. So it's really like production quality as much as Python 3. But you can't run Mypy using Python 2, but that's no problem. You can probably install Python 3.
Hi. Will Guido be angry if Python becomes statically typed language?
Guido is totally behind, and he's actually working on Mypy. So yeah, it's not like Python is not becoming a statically typed language. This is totally optional. So it's for basically, mostly for large projects and large code bases. It's really helpful. So this is just one tool in the toolbox. So use it if you think it's useful. If you only have like small project that you work on, then probably it doesn't make sense to learn it. It might still be useful, but it might not be worth the kind of investment in kind of learning this stuff.
Is there some fundamental problem with creating typesets for PsychoPG, because it's like a very popular project and it still, shows us cannot import, stuff from PsychoPG2? Like, do you know something about that?
I'm not sure about this particular library. It might be just nobody has kind of contributed them. Because if sometimes it's just so simple to write the stubs yourself. If everybody writes their own set of stubs, and then nobody contributes them back. So I recommend trying it out. There's a subgen utility shipped with Mypy. It's not kind of well documented, but it's there. So I recommend trying it out. Often it's kind of straightforward. Unless it's a really big library like Django, then that's actually like, I wouldn't recommend starting out with that because it can take a lot of work.
Do you have any metrics of what kind of quality improvements you get, or how much do you speed up the coding process?
This is something it's really hard to have like hard metrics. But from Dropbox, like we periodically somebody said like, oh, we had an outage or some kind of like production issue that would have been prevented if the code would have been type annotated. So it definitely, but things like if you prevent something, then that's, how do you know? Because it didn't happen. But basically people, we get a feedback from users and they're really happy. They say like it accelerates it. So it's like a subjective thing. But when working on a large code base, we're pretty convinced that it's mostly a win. Once you get like the initial, some level of type checking coverage, then it gets really helpful. But initially you have to like do a bit of investment. If you just annotate one single file, it's not that helpful.
Thank you. We have time for a last quick question.
How do you imagine some library a library wants to support some multiple other dependencies? and in one of them we expect something to some type, and the other one, and the updated one, we expect another type. How did you deal with such things?
Sorry, can you repeat the question? I didn't quite hear it.
Imagine that our library depends on some other library, and from one version in that other library, the type changed. How do we deal with such things in Mypy?
So if you have a third-party library and the signatures change, so TypeSheet can only have like one version at a time, but we support like pip installable stub packages. So you can have like multiple versions of the stub package corresponding to different versions of the library, and then you just like pin the correct version of the stub package, and you get a correct type checking. So that's probably the best option.
Yeah. Thanks. By the way, I admire your courage to write such a huge library alone.
Okay, fantastic talk. Thank you, Jukka. Let's give a hand to Jukka.